Hi guys, welcome back to my channel. So in today's video, I'm going to talk about the Fermat's law theorem and the Wilson's theorem. So I'm going to split the content into two parts. So this video is part one, and I'm going to be focused only on the Fermat's law theorem. So now let's dive into the contents. The Fermat's law theorem states that a to the p power is going to be equal to a mod p, and a to the p minus 1 power is going to be equal to 1 mod p. And this theorem only works when p is a prime number and not equal to a. So now let's work on example 1. 6 to the 16 power is equivalent to what number in mod 17? Notice that 17 is a prime number, so we could use the Fermat's law theorem in this case. The Fermat's law theorem states that a to the p minus 1 power is going to be equivalent to 1 in mod p. And in this case, 16 is equal to 17 minus 1. So immediately we know that it's going to be equivalent to 1 in mod 17. And basically that means that 6 to the 16 power divided by 17 is going to have a remainder of 1. Now let's take a look at example 2. So first, we know that the number 7 is a prime number, so we could use the Fermat's law theorem in this problem. And according to the rule, any number to the 6th power is going to be equivalent to 1 mod 7. So in this case, 11 to the 6th power is going to be equal to 1 mod 7. And now we could break this exponent number down to smaller parts and find the remainder of each, and then multiply them and find out what the final answer would be. And I'll show you what I mean. So first, let's divide 34 by 6, and we would have 5 with a remainder of 4. So we can actually rewrite this 11 to the 34th as 11 to the 5 times 6 power times 11 to the 4 is equal to what number in mod 7. So let's find the remainder of this part first. 11 to the 5 times 6, we could also rewrite this as 11 to the 6th power with 5 in outside times 11 to the 4th. So what we can do is, since we know 11 to the 6th has a remainder of 1 when it divides by 7, we can just substitute this 1 into the parentheses. So we would have 1 to the 5th power times 11 to the 4th. Let's just break it down to 11 squared times 11 squared, which is 121 times 121 is equivalent to what number in mod 7. So we can just cross out this part because it's just going to be 1. And now let's figure out the remainder of 121 divided by 7. So 121 divided by 7, 751 and 749. And we are going to have a remainder of 2. So same as this part, we can just substitute a 2 for 121. So we would have 2 times 2, which is going to be 4. So 4 would be our answer in this case. Now let's move on to example 3. So here we have 3 to the 500 is equivalent to what number in mod 11. So based on the Fermat's law theorem, we know that 3 to the 10 power is going to be equivalent to 1 mod 11. And 500 divided by 10 is 50 with a remainder of 0. So we can rewrite this as 10 times 50 is equal to what number in mod 11? And then it will be 3 and then 10, and we have a 50 on the outside. Now just substitute this 1 in to the parentheses, and we have 1 to the 50. And in this side, we will just get 1. So 1 would be our final answer for this. So when 3 to the 500 power divided by 11, we would have a remainder of 1. And you stop finding the remainder when this number is smaller than the mod base. So now let's move on to example 4. 45 to 20 is equivalent to what number in mod 17? So in this case, we can use the Fermat's theorem again, since this number is a prime number. So first, let's write it out that 45 to the 16 power is going to be equivalent to 1 mod 17. And now let's break this exponent apart. So 20 divided by 16 is going to be equal to 1 with a remainder of 4. So we can rewrite this as 45 to the 1 times 16 power times 45 to the 4 power is equal to what number in mod 17? And now, since we know that 45 to the 16 power is 1, we can just substitute this with this number. So we would have 1 times 45 to the 4th power is equivalent to one number in mod 17. Now cross out the 1, and we can find the remainder for 45 first, and then to figure out the final answer. So what we have to do is use 45 divided by 17, which is going to be 234, and the remainder is 11. So we can just substitute it. 11 to the 4th power is equivalent to what number in mod 17? Again, this will be equivalent to 11 squared times 11 squared, which is 121 times 121. Now simply just divide 121 by 17. And you will have a remainder of 2. So 2 times 2 will be equal to 4. So the answer will be 4 mod 17. Now let's solve for a more challenging problem. Now let's just try this problem on your own and click pause, and we will go back to this later. Okay, now let's solve this problem. So 2 to the 2021 is equivalent to what number in mod 13? Based on the theorem, we know that 2 to the 12th power is going to be equivalent to 1 mod 13. So use our steps, which we will divide this number by 12. 2021 divided by 12, 112, 82, and then we would go with 6, 72, 101, and then 8, 96, and we would have a remainder of 5, so it's 168 with a remainder of 5. So now let's rewrite these exponents, and we would have 2 to the 12 times 168 power times 2 to the 5th is equal to what number in mod 13. And this is basically going to be equal to 1, because you can rewrite it as 2 to the 12 to the 168, and once we substitute a 1 in, it's going to be equal to 1. So we can just cross it out right away. And we're left with, this is going to be equal to 32 is equal to what number in mod 13. So now let's use 32 divided by 13, which is going to be equal to 26, and then we would have a remainder of 6. So our answer is going to be equal to 6 mod 13. Thank you guys for watching this video. I hope this video is helpful, and we'll see you in part 2. Bye!